Hello everyone. In this video we are going to study a well-known pattern in Solidity, the Beacon Proxy. Delegating proxy contracts are widely used for both upgradability and gas savings. These proxies rely on a logic contract, also known as implementation contract, that is called using delegate call. And this allows proxy to keep a persistent state, storage and balance, while the code is delegated to the logic contract. So EIP-1967 standardizes where proxies store the address of the logic contract they delegate to. And the beacon solves the problem of updating the logic contract of a proxy, because usually you have to do it one by one, but with the beacon it becomes possible to update all the proxies at once. And this is really useful when your application needs to create a lot of contracts. And by the way, you will find the GitHub repository in the description for the code I'm going to show you. So let's start with Remix. We will have a vault contract with a factory contract, and the factory must be able to create vaults. And vaults will be with proxy at each deployment. So first, we need to import the OpenZeppelin contracts that facilitate the creation of a beacon proxy. The first one is the initializable contract, and basically it replaces the constructor due to a requirement of the proxy-based upgradability system. And then we need the beacon proxy, and this is a proxy that will be deployed each time and points to the logic contract given by the beacon. And eventually we have the upgradable beacon, and it's the contract that offers the upgradability feature. So let's start with the Vault v1 contract, which is a very simple contract with an initialize function that is protected by the initializer modifier from the initializable library contract, and in it we have the function down that lower the variable value by 1. Then we have our upgraded contract, Vault v2, which is exactly the same except that you have an additional function called up that increases the variable value. Nothing special here. And then we have the real stuff about beacon. The first one is the Vault beacon. So this is only a beacon that will serve the proxy to fetch the address of the implementation. And at construction, you see that we create an upgradable beacon, so the OpenZeppelin 1, and we have an update function which upgrade from a logic 1 to a logic 2. And basically, this is only this. You have an update function and an upgradable beacon in it. And this Vault beacon will be created when we deploy our factory contract. And our factory contract is just a mean to create vault. And each time we create a vault, we'll create a vault based on a given implementation of the beacon, and we'll create a proxy that points to the logic implementation, the logic contract. And this is what the create function does. So it creates a beacon proxy. There is some stuff about the encode of the data, because it's used via the delegate call feature. So we have to give the selector of the initialize function and then the arguments correctly encoded, and that's it. So now we are going to compile the whole code and test it in Remix. So you can compile the code and deploy a Vault v1 contract. You select Vault v1 and you deploy. And you can see here we have the Vault v1 structure. Then we can create the factory with the Vault v1 contract. And remember that in the factory, in the constructor factory, we'll create a Vault beacon and this vault beacon will be used each time we create a vault, and it will be used to refer to the real implementation. So we take the vault v1 address and deploy the factory with it. So now we have our factory. You can see we have a beacon and an implementation contract, which is the same as the vault v1 logic contract. Now we can create a vault via the factory, and you can see here we have our vault. We can also create another vault, Alice, with 19 and index 2, and now we can instantiate this vault via Remix by telling to Remix we have this contract, which is in reality it's a proxy that is running on a vault v1 structure, and we tell this to Remix by using the @address button. And so now we have a vault v1 and we can interact with it by using the function down. And we also have another vault v2. Now we have another vault v1 created via the factory. You can take the address here, and we are going to do the same. We're going to tell to Remix we have a vault v1 running at this address, and here it's a Alice vault, and you can see with the value. And now let's say that we want to upgrade the logic of our vault, and you can imagine that we have like hundreds of contracts running on the same implementation. In our case, if there is only 2, but it could be a lot bigger. We can update the implementation by using the beacon, and the beacon is running at this address given by the factory. So at this address we have a beacon. We're going to tell this to Remix by the button @address, and you can see here we have our beacon with the vault v1 logic. And to upgrade the logic contract, we are going to deploy the vault v2, which is the future logic of the vault, like this. And now we have our vault v2. We take the address of vault v2 and we update via the vault beacon the address of the implementation. So now it's done. So now that we have deployed the v2 implementation and upgrade the beacon to the new v2 implementation address, we can tell to Remix that our contract has been updated. And to do so, we can take the contract via the getVault function at the index 1 for the first vault, and we can tell to Remix that a vault v2 is running at this address. And remember that this address is just a proxy that delegates call to the implementation given by the beacon. And as you can see here, we now have the function up, and this function up is only present in the v2. So our upgrade worked, but we can check this by using this function. You can see the value here is 39, and we have the function up, which is working, you can see below, and the value increase. And you can also directly check that the upgrade has been made on every vault by taking the second vault here and doing the same. You tell to Remix that the vault v2 is running at this address, which is a proxy address. And here we are. We have our vault v2, the Alice 1, with the value 19 and the up function. And you can notice that in only one transaction we've upgraded multiple contracts, and this is the huge advantage of the Beacon Proxy pattern. That's it for this introduction on the Beacon Proxy. You will find most of the resources in the description. And thank you. See you in a future video on Solidity. Bye.